Hi, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic is Laser Beam Machining Problems and Solutions. Okay, right. At the end of this session, student will be able to solve the problems on material removal rate of laser beam machining. Of course, if material removal rate is given, some other parameters may be asking in the problems. So the student can be able to solve whatever it may be the question. Right. Now, calculating energy required for material removal rate. Okay. Problem number 1. Calculate the energy required to remove 10 milligrams of material using a laser with an energy absorption efficiency of 50%. Okay, so 50% means 50 by 100, that is 0.5. The material's specific energy requirement for vaporization is 500 joules per gram. Okay. Now, mass of material to be removed 10 milligrams. Okay, so we have to convert that mass of the material to be removed from milligrams to grams. So by 1000, that is equal to 0.01. Okay, right. Energy required for vaporization equal to 0.01 into 500 joules per gram, that is 5 joules. Okay, so energy required for vaporization is nothing but material to be removed multiplied with the specific energy vaporization. Okay, right. So energy supplied by laser equal to, the formula is that this energy required for vaporization by this 0.5. What is 0.5? Efficiency. Okay, energy absorption efficiency. Okay, so finally the laser must supply 10 joules of energy to remove 10 milligrams. So, okay, in order to remove the 10 milligrams of the material from the workpiece, how much power is required? 10 joules. Okay, here energy, let us say. Okay, right. Next, problem number 2. Determine the cutting speed. Okay, a laser beam with a power of 200 watts is used to cut a material with a thickness of 2 millimeters. The material has a specific energy requirement of 1200 joules per centimeter cube. Calculate the cutting speed in millimeters per second. Okay, right. Now, volume removed per second. Okay, volume removed per second. The formula is that laser power by specific energy requirement. Okay, laser power by specific energy requirement. Okay, so volume removed per second can be calculated by using this formula. Okay, right. Is laser power given? Yes, 200 watts. Okay, 200 watts is given. Okay, that is 200 joules per second. Okay, 1 watt equal to joules per second. So that's what here written. Okay, and specific energy requirement is given. Yes, 1200 joules per centimeter cube. Joules per centimeter cube. So joules gets cancelled. So this centimeter cube will go up by second as usual. Okay, so this value is 1 by 6 cubic centimeters per second. Okay, right. So here cutting speed in millimeters per second we want. Okay, so for what we have calculated volume removed per second. Okay, volume means cubic centimeters we got. We can convert into millimeters. Okay, right. Cutting speed. Cutting speed formula is that volume removed per second by cut area. Okay, so volume is nothing but cut area into cutting speed. Okay, so volume removed per second equal to cutting speed into cut area. Okay, from that cutting speed equal to volume removed per second by cut area. Okay, right. So substitute the values. Okay, so we got this value is 1 by 6 cm cube per second. Okay, and cutting area equal to 2 mm into 1 centimeter. Okay, so here we have to convert this mm into centimeters, so that value is 0.2. Okay, so here this value is given in millimeters, so we have to convert. Okay, 2 by 10, that is 0.2. So 0.2 into 1, 0.2. Okay, 0.2 cm into cm square. So here cm cube, cm square. Okay, cm will remain. So cm per second. So 5 by 6 cm per second. Okay, so convert that cm into millimeters. Finally, we get 8.33 millimeters per second. Okay, so the cutting speed is approximately 8.33 millimeters per second. Okay, right. Next, third problem, laser spot size calculation. Okay, a laser beam with a wavelength of 1 micrometer is focused using lens with a focal length of 100 millimeters. Calculate the spot size diameter at the focal point if the laser beam has a diameter of 10 millimeters before focusing. Okay, so let me read this problem once again. A laser beam with a wavelength of 1 micrometer. So wavelength is given. Okay, so wavelength is given. Wavelength is given. Okay, is focused using lens with a focal length. So focal length is given. Now calculate the spot diameter. So we need to find spot diameter. Okay, if the focal point, if the laser beam has a diameter of 10 millimeters. Okay, so here laser beam diameter is given. Right. In order to find the spot size diameter, we have formula 4 into wavelength into focal length by laser beam diameter before focusing. Okay, so substitute the values. Focal length given, wavelength given. This one is focal length given and laser beam diameter before focusing. Okay, so these three numerical values are given, directly substitute. Okay, so here the thing is that here 1 micrometer is given. Okay, wavelength for 4 no issue into 1, but we have to convert into meters. So 10 power minus 6. To convert into meters, we have to multiply with 10 power minus 6. Okay, next focal length, how much? 100 mm, no issue, 100, that is mm, but to convert into meters, multiply with 10 power minus 3. Okay, by laser beam diameter. Okay, how much given? 10 mm. Again convert into meters, 10 power minus 3. Okay, so here 10 power minus 3, 10 power minus 3 gets cancelled, and simplify the rest of the things so that we will get some value in meters. Why? Because we have converted all these things in meters. Okay, so if we get the meters value, then again multiply with 1000, sorry, 10 power 6, we get in millimeters. Okay, understood? So here this one will get cancelled. Okay, this one gets cancelled. So finally this one will remain. Okay, so finally 10 power 4 into 10 power minus 5. So finally in the value is 0.04 millimeters. Okay, so take care about these units. Nothing issue here, no issue here. So we get, once if we get in meters, just convert into millimeters. Okay, so 1 meter equal to 100 centimeters. Okay, and 1 centimeter equal to 10 mm. So 1000 millimeters. Okay, 1 meter equal to, right? So by 1000. Okay, right, no issue. That's conversion is very simple. So the spot diameter at the focal point is 0.04 millimeters. Okay, so with this the third problem has completed. Right, fourth one, heat affected zone width calculation. Okay, how much width of the heat affected zone would be in the given problem that we have to find. If the thermal diffusivity of a material is 1.5 into this value, some square meters per second, okay, and the laser exposure time is 2 meter seconds, calculate the width of the heat affected zone. Okay, so heat affected zone width formula is that 2 into square root thermal diffusivity into exposure time. Already in the previous presentations we have seen that. Okay, or 4 alpha T, 4 alpha T, this one T, sorry. Okay, alpha is the thermal diffusivity and T is the exposure time. Okay, already we have seen this heat affected zone width formula. Okay, the same here. Okay, now simply substitute here. Okay, you take this one only, no issue. Okay, and finally we get this value. Okay, upon simplification we get 0.346 millimeters. Okay, right. So for heat affected zone, the formula is that square root 4 times thermal diffusivity into exposure time. Okay, so either you can use that formula or 2 into square root of thermal diffusivity into exposure time, no issue. Okay, right, here you need to take care about the units. See here 1.5 10 power minus 6 square meters per second. Okay, and thermal diffusivity is over. Next, laser exposure time 2 meters per second. Okay, so we have to convert. Okay, and finally we get in meters. Okay, 2 meter seconds, this one. Okay, understood? Next, determine the material removal rate. Okay, problem number 5. A laser with a power of 150 watts is used on a material with a specific energy requirement of 600 joules per cubic centimeter. The laser cuts a groove 0.1 centimeters wide and 0.2 centimeters D. Calculate the material removal rate in cubic centimeters per second. Okay. So here we have formula. Material removal rate equal to leisure power by specific energy requirement. Okay. So here leisure power is given 150 watts leisure power, and specific energy requirement 600 joules per cubic centimeter. So finally we get 0.25 centimeter cube per second. Okay, and the laser cuts a groove of 0.1 centimeters wide, and all these things are the superfluous data. Okay, the material removal rate is 0.25 cubic centimeters per second. Okay, so this data is not required in order to calculate the material removal rate. Okay, right. Sixth problem. Calculate laser energy density. Okay, calculate the energy density of a laser beam with a power of 50 watts focused to a spot size of 0.05 millimeters in diameter. Okay, so here what is the given data? Power is given 50 watts. Okay, and spot size is given 0.05 millimeters in diameter. Okay, now we have to calculate the area of the spot size first. Okay, so in order to find the area, pi r square, okay, or pi d by 2 square. So that's what we have written. Okay, pi into diameter by 2 square. So substitute the values so that we get pi diameter how much? 0.05 mm. Okay, 0.05 by 2 whole square. Okay, so that we get 0.025 whole square, and pi into that value. So finally the value is that 0.00196 mm square. Okay, that is the area. Once if we calculate the area, the energy density equal to laser power by spot area. Okay, laser power by spot area. What is the laser power? 50 watts. Okay, and the spot area. Okay, the spot size area is 0.00196 mm square. So we have to convert that one to meters square. Okay, so finally it will be in watts per mm square. Okay, right. The energy density of the laser beam is approximately 25,510 watts per mm square. Okay, so here the thing is that formula and substitution. Okay, just in the first problem we need to submit the values directly. Okay, no issue. And in the second problem, volume removed per second is nothing but laser power by specific energy requirement. Okay, next in the third problem we have formula. Okay, for spot size diameter 4 times wavelength into focal length by beam diameter. Okay, laser beam diameter. Okay, now in the fourth problem, okay, heat affected zone width or depth, okay, can be calculated using square root 4 times thermal diffusivity into exposure time. Okay, next in fifth problem, material removal rate can be calculated by using this formula, laser power by specific energy requirement. Okay, the sixth problem, first we need to find the area. Why? Because energy density equal to leisure power by specific area. Already we know power equal to energy density into area. Okay. So obviously energy density equal to leisure power by spot area. Okay. So here spot area is not given. So we have calculated here. Okay. So that's it. So with this, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.